Hello, everybody. Welcome to Alliance Science Seminar Series. As you already know, this is a series dedicated to knowledge sharing, to exchange our knowledge through the whole Alliance research teams. And today is our seminar number 32. So yeah, a lot of seminars this year, and we're very happy for that. Always, I'm Jose Antonio Arana, your seminar host, and today we have a seminar called Data Analysis Pipeline in Cassava Breeding, and with us is our presenter, Luis Fernando Delgado. He's an agroindustrial engineer with a master's degree in agricultural science and experience in managing, processing, and analyzing plant breeding data. His professional career has involved international collaborations in France, Southeast Asia, and the Americas. And his work has ranged from the collection of breeding populations to their evaluation and characterization for agronomic and culinary quality traits. Luis currently works as a data scientist for Cassava program and also a university professor. So throughout his work, Luis has used
Sorry, can you hear me, please?
Yes, we can hear you.
Yes.
Okay, the problem is with the presenter.
Yes, he lost the connection.
um, okay, let's wait for 1 minute to see if he shows up. Otherwise, I can start. Okay, I'm going to start. Hello, everybody. Good afternoon, good evening, or good morning, whatever you you are in this moment. Today, I'm going to talk about data analysis pipeline in our program of cassava breeding here at CIAT. First of all, this is the main summary flow diagram that I'm going to talk. I'm going to talk about data collection, the methodology that we are currently using to collect the data directly in the field, in the lab. After that, I'm going to talk a little bit about the data storage directly into our database called Cassava Base. And then I'm going to talk about the different steps that I am running in this moment to analyze the phenotypic data. This is the all tools that we are currently using. All the process are 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 making using R and RStudio and different libraries like QBMS. I'm going to talk about this later. Agri-utilities as well, HTML R. This is a licensed library. It's no open source. We need to pay for using, but it's very useful to analyze, especially multi-trial analysis, and of course Cassava Base. This is the logo of Cassava Base, where we can storage all of our data, and Fieldbook. Fieldbook is the application that we use to collect the data. Um, like I said before, the first step, start using Fieldbook. Fieldbook is an open source Android app that is used to collect data on field, directly on field. It can be downloaded directly from App Store or App Store. I'm not quite sure if this application is available for iOS, but we need to try. And this application is part of the Feno apps suite. This application is useful because it allows us to, like I say, you collect phenotypic data, navigate between plots or tracks, like you can see here. We can cus- cus- customize cus- customizable. It's very customizable because it allows to collect different kind of traits. For example, numeric traits, categorical traits, traits based on percentage, dates, Boolean variables. Even this application allows take a picture, make some recording in case that we had seen very some important in the field. Counter, it allows also to put a localization, a location where we are in the moment that we collect the data. Anyway, this application is very customizable. The second step is storage all data into the Cassava Base. Cassava Base is our center data, where we can storage all our data, including genotypic data, phenotypic data, and even data from NIRS spectral data. Cassava Base is part of the breed-based system. This database allows to have all traits taken in a standardized way using the phenotypic ontology. And the main goal of this database is to provide a standard web application or a standard web interface, very friendly for all breeding tools, phenotype, genotype, spectral data. One of the most advantages that this database has is manage accession and pedigrees in a database with ontology based on descriptions, log historical data. This is a very important part of this database, useful for me, because this database had allow me to download all historical data, especially the historical data of all program, 50 years of data, and in this moment, this data is being analyzing. Collect phenotypic data as well, using even cell phones, tables, manage phenotypic data, and one of the main functionalities that this database has that is not very used for breeders is data analysis. Through Cassava Base, we can calculate, or we can make calculations, for example, heritability, single bloods, single bloops, component analysis, principal component analysis, stability analysis, AMI. Most of the normal, or yes, most of the normal data analysis that I have through R database is able to run them. Here, this is the web page where you can go and see and look at the Cassava Base web page. Then once the data has been stored in Cassava Base, now the next step is download this data. Cassava Base has three different ways to download data, but I like to use the way using QBMS. QBMS is a data management system to analytics. Because it's important in these all kind of steps in breeding digitalization. Most of the breeders can use this R package to query the breeding management system in different central database like BMS. Breed Base is our database. Remember that Cassava Base belong to Breed Base Swift. Jigwa, okay, in this moment I'm not remember the other. And also this package help me, for example, to retrieve phenotypic genotypic data. But in this moment, I am only retrieving just phenotyping data, no genotypic data. Last year, I elaborate a manual to download the historical data from Cassava Base, historical data of Cassava program from Cassava Base, and you can access through this link. So if you are curious and want to know how to download historical data or just single trials, you can access to this manual and read it. Okay. Now, I'm going to start to the part of exploratory data analysis that is below of the data analysis main process. Once I have the data download from Cassava Base, I start doing some EDA or some exploratory data analysis. One of the first steps is to know some general information about trials conducted, that at the moment I was analyzing. For example, here I have 5 different trials. So I like to print out the plant date, the harvest date, the harvesting time. It means the time that agronomists take to harvest the plants or the different plots in the field. The location is so important to know where the trials are located. For example, in this case, we have 4 different locations: Santo Tomas, Repelón, Momil, and Palmira. Most of our trials are conducted in the north coast of Colombia. And always we have a copy here in Palmira, in CIAT Palmira. Other thing that I like to print out is to know, for example, the number of plants harvested per plot, to know how many plants were used to calculate in this case the yield. So this is the way that I used to know the most frequent number of plants harvested per each trial. And also I like to print out a map. So in this case, it's a Colombia map. Other thing that I like to see is the trial layout, because this kind of print allows me to know a little bit more about the way that agronomists use to plan the trial. So as you can see here, guys, most of the trial has in this moment two replication, except this trial, and this trial correspond to Palmira. Like I said you before, Palmira in this case is working as a copy, as a German plus copy of all of these other trials in the North Coast. The check varieties, it means the controls or the check varieties are completely randomized, and the experimental design that we are using in this moment in the Cassava program is a roll call design, a resolvable roll call design. I also like to know which checks were used to control the error. And all of the checks that the Cassava program uses in this moment are released varieties. So as you can see here, this one is the Costeña variety, Veronica, Venezolana. This variety is mostly can find in the supermarkets, but not all, just the most common. Other the other thing that I like to print out. This is part of the EDA exploratory data analysis. Um, Other thing that I would like to see and to look at is the different tricks that were taken in the field. So, for instance, here we have several tricks, around 20 tricks taken in the field, including so in this case, quality tricks like water absorption at 20 minutes, water absorption at 30 minutes. These two traits are part of the cooking quality traits, and the rest are part of the agronomic traits taken directly in field. And I also like to see the number of the percentage of missing values per each trait within each trial. So for example, here, lodging at 6 months, in most of the traits of the trials didn't take it. Only lodging was taken in one trial, and this is the trial where lodging at 6 months were taken. Other layout that I like to print is the connectivity matrix or the chirp matrix to know how many genotypes are common among these among all of the trials or between each trials. This is a very useful way to know the most common genotypes between trials, because this allows me to know how much accuracy is going to be the G/E analysis. So in this moment, I found two big groups. One of the groups had around 400 common genotypes between these three trials, and the other group had around 800 or 700 genotypes across these other two trials. In general or in total, I found two different groups. This is part of the multiple correlation trait. It allows me to know the different relationship that we can find between different traits. So in this moment, I can see, for example, yield is very correlated in this moment with dry matter yield by hectare. That is obvious. Other good correlation is germination percent. As you can see here is 0.8, is so correlated with germinated number plot. Is very, very obvious. But remember, guys, in this moment, I'm just using the phenotypic value, the raw data. I'm not using not even the mean, and not other estimates like loss or blobs. This is the next step of the analysis. Once I knew the different relationship between different traits, I like to print, for example, here the variation of each trait within each trial. It's just to see mainly the G/E effect. So as you can see here, for example, a root weight plot. Let's zoom in this box plot. As you can see here, guys, the root weight plot response, or the root weight plot variable or traits, had a G/E effect, because in this trial, 2000 2257 dBGST at the Momil location, the variation was less than the other trials. So this box plot or this plot helps me to know how much the variation across trials was. I want to highlight this trait. This trait corresponds to CBB. It is a disease. So in this moment, this trait was only taken in one trial. This trial was in the repellent location. So here you can see that all values correspond to 1. Okay, let's keep in mind this for 1 second. Now I'm going to talk about the statistical data analysis. So as I told you, the CBB at 3 months didn't have any variation across different trials, but so in this moment we only taken in one trial, but even we didn't have any variation. So that is the reason that I dropped it from the rest of the analysis, because I am only interested in the traits with variation across different trials, which trait was severity of cassava bacterial blight. Like I told you, is a very serious disease. But fortunately, here at CIAT, all of the plants that were measured show were in a healthy condition. So that's the meaning of 1. If you want to know more about the different variables or traits that we taken in the field, you can go to the Cassava Base ontology. There you can find the different definitions from all traits that we took, not only for CIAT, also for all centers that work with cassava. This photo was taken from a very friendly and useful manual. It's a SOP, a standard operation procedure made here at CIAT by our researcher Sandra Salazar. You can go and see the different traits that we take here at CIAT. Okay, as first part, the first part of the data statistical analysis is the spatial analysis correction. Like I told you before, in the first or second or third slide, I told you that the experimental design that we are currently running here is a row call or resolvable row call design. This kind of experimental design allows us to correct the spatial variation. And this is the way that I use to correct the spatial variation using a library called SPATS. So SPATS is installed in other libraries developed by one of the previous researchers we used to have here at CIAT. His name is Johan Aparicio. Johan Aparicio developed these two very nice packages. Mr. Bean is a visual interface or user interface web page or web application developed in Shiny library. This is very useful, especially for people that don't have so much code skills. And the other very nice library is AgroUtilities. This is the library that I use, AgroUtilities, to correct this spatial variation. And in the backend has the SPATS library to correct the spatial variation. So here we can see the raw data. This is the raw data, the normal data that the agronomist takes in the field. The fitted data correspond to predicted data. The residuals correspond to the error of the model. And here we can find for example, in this case, this is for yield, for yield trait. We can find the variation of the yield that is not due to the genetics and doesn't depend on the row and col positions. This correspond to error. And here in fit spatial trend, we can find the yield variation along rows and columns that is not due to genetics. This is the spatial correction that we did. Try to separate the genetics effect from the spatial or field effect. Once I have corrected the spatial variation, I'm going to proceed to calculate the heritability. Follows this formula. This is a very easy formula to implement. It's just put the genetic or the genetic variation, or so in this moment is the genetic variance under the genetic variance plus genetic error variance per number of reps. This is the way that I use to calculate the heritability. So remember that the heritability ranks from 0 to 1. 1 corresponds to high heritability, a very nice heritability, and this show us how much how much or yes, how much we can trust in the trait taken. If the heritability is close to 1, is because the trait taken is very reliable. And if the heritability is close to 0, is because the trait is not very reliable. So we need to be careful with the traits that are close to 0 in base of heritability. Here is the report of single heritability. Here we can see 4 different traits with several, 4 different trials with several traits. So, for example, here we can see a heritability close to 0, and this trait is lodging. Lodging is when the plants fell down in the field because of strong winds or other environmental events. Other very low heritability is, for example, this one. This one is very close to 0. This corresponds to trips pressure on this trial. So as I can, like I told you, we need to be cautious with the traits with very low heritability. We cannot trust in these kind of traits. For the G by E analysis, the decision that I made is drop it those traits with very low heritability, because those are going to affect the G by E analysis. So it's better to get rid of it. The next step is try to or calculate the G by heritability across all trials. So here we can see that the most of the trials had a very good heritability, range from close to 0, 0.97 to 0.4. The rest of the trials, or the rest of the traits had very low heritability. So again, for traits with low heritability, the breeder needs to be very careful, especially at the moment to make selections. Other step that I like to print out is to see the genotypic correlation across trials. So here, this is the way that we use to see how much were the different trials, or in this case, the different location related based on each trait. So, for example, here for yield, this trial conducted at Pomil location in year 2022 had a very low correlation with this other location or this other trial conducted on 2021 at Momil location as well. But the difference between these two trials is the year, because one was conducted in 2021 and the other in 2022. So here we can see a very a strong GR effect. Basically, the GR effect had the fall because of this very negative correlation between these same location trials conducted at different years. For the rest of the traits, for example, dry matter, plant type, height of the first branch, especially dry matter and plant type, we can see a very good relationship or very good correlation across different trials, except for height at first branch. Now, this is the genotypic correlation across trial using estimate called blob. With this estimate, we are very confident about the different genotypic or different genetic effects of each accession. So in this moment, we are confident to conduct or to run this kind of correlation analysis. And here we can see the reality of the relations across across different traits. For example, dry matter yield per hectare is very negative correlation with root type. This is really true. Root type is a very nice trait that the agronomist takes in the field, and root type it corresponds to the size of the roots, the length of the roots, and other visual characteristics of the roots. But root type, the best root type is 1, and the worst root type is 5. So that is the meaning of why we have a negative correlation here. Other, let's find other very good correlations, especially related with plant architecture. Okay, branch number, branch number. The number of branches is very negative correlation, very negative correlated with height at the first branch, and this is totally true, because this is one of the main objectives of the breeder, try to make the height of the first branch higher and branch number less. Then once we have the different blobs, the different blues per each trial within per each genotype within each trial, we can conduct an index selection. So in this moment, the methodology that I am using to calculate the different weights to index selection is very subjective. The plan, the near plan, is try to adjust this methodology to economical weights, because in this moment the ways or different ways that we are using with the breeder is just, for example, to dry matter, we can score as 10, plant type we score as -5, and yield we score with 10. So these three scores allow us to calculate an index. Here you can see the vector index, and if you can look at, you are going to realize that index is very close to yield and dry matter, and that is that we need. Try to select all genotypes close to these vectors. This is the way that selection or the index selection works. So here you can see all population that was or that were tested in different trials, and the genotypes that were selected close to index vector, and of course close to dry matter gravity and yield by per hectare as well. This is just a help, a way that the data scientist has to help the breeder to make the selections. Once we have the selection index, the blues, the blobs, and the different estimates across different trials, the breeder print out this table. This table is the end of the process, because this table corresponds to those accession or those clones that are going to advance to the next breeding stage. So, for example, here the breeder puts here a column called advance. So in this case, our breeder is Xiaofei Sham. Sorry for not mentioning him before, but Xiaofei just put here based on the results and based on his knowledge which genotypes are going to advance to a next breeding scheme step. So, for example, here, this genotype had a very high dry matter and a very high water absorption. Remember that water absorption is a cooking quality trait, and this is why he decided to advance to next stage. Other is this one with high dry matter, and as you can see that the different genotypes that he used to move on. Here is the index selection that I print as well, and the rest of the columns correspond to blobs or the estimates using to know the performance of each section across each traits. When I finish all process, I storage the code, the results, the different plots and the different figures in this. This is all Cassava 2050 GitHub account. Is public. You can go see what I am doing in this moment. Please, if you are curious, go make me a pull request to improve the code skills or the code writing way. This is the main summary of the all data analysis process that you already know. All data comes from database called Cassava Base. Once we have the data download, we have the raw data. The raw data was curated by manually using Excel or R script. Once we have the curate raw data, we can proceed to do the some extra cleaning process. This extra cleaning process obtains the tidy data, and then once we have the tidy data, we again clean the data because we can eliminate or remove some, for example, outliers that the model is able to detect. And then we have the results data, the main results of the data analysis, and then the last report of the advancement report. This is all the tools that in this moment we are using, except BitCell and Spotfire. I'm not using these two tools. And that's all. Thank you so much for your presence.
Thank you, Luis Fernando. Thanks a lot. Now we have some time for questions and comments. I've seen one in the chat box from Thierry. Thierry, would you like to open your mic and make the question?
Yes, thank you. So I find the presentation very interesting, although I arrive a bit late. But I saw the table for the selection index. Hi, Luis. And so the selection index is the combination of the different criteria. And my question is there a process or a protocol to define the weight of each criteria? Like, are they all the same importance, or do we give more importance to some criteria and less to others?
Yeah, so in this moment, we are giving more importance to any specific traits over the others. And that is the why we need to improve this kind of make selection index. But remember that this is only a help for the breeder, because the last decision was made based on the blue values. For example, here you can see that this variety, GM8867, was selected because high dry matter and high water absorption. And water absorption was not in the selection index. But yes, you're right. You're right. In this moment, we are giving more importance to any specific traits over the others. We need to improve that.
Yeah, it's just out of curiosity. So yeah, the water absorption is not yet in the index.
No, not yet. Not yet.
Okay.
Not yet. Not yet.
That would be good to get there. Thanks a lot.
Yeah, it would be good to get there, but I don't think this moment is it be necessary, because the cooking quality trait is so important for the program, and this is one of the main reasons to select the different accession. They have a very cooking very high cooking quality.
Yeah, I see. I totally agree. Thanks.
Good to have you here, Thierry.
Yes, good to be here too. I saw Luis was going to present, so.
Yeah, happy to see you again after a long time. Okay, thank you.
Okay,
thank
Sebastian,
you.
go ahead.
Yes, a very impressive presentation of the pipeline of the cassava analysis. My question would be, do you provide this as a server to the scientists, or the scientists mainly need your input to perform this whole analysis? Because the reason why I'm asking is that I think many of those tools can be extrapolated to other crops, because many things, the way of analyzing is not specifically for cassava, and I guess people from other crops can learn a lot. So the question would be, are there any initiatives to see how this pipeline can be rolled out across different crops, not only for breeding, but also for the gene banks, if we start phenotyping gene banks?
Okay, your specific question is to know whether is there any initiative?
Yeah, so okay, you invested a lot of energy in developing this pipeline. The question is basically, did you talk to colleagues working with other crops to see how things can be rolled out, and that we can learn from each other, and or is this only for the moment like a service you provide towards the cassava breeders?
Okay, so in this moment, we developed this whole pipeline by only using the breeder knowledge and mine as well. But yeah, now we start to talk with other colleagues from other centers to put all together this kind of analysis with other crops. And if I'm not wrong, the initiative is called let me look at, but I'm talk with a lady called Dorcas. I don't know if you maybe know her, but Dorcas is the person that is in charge of this initiative, accelerated breeding. And here in this initiative, we can find different scientists across other crops that are working with this kind of analysis. Not exactly the same, but very quite similar, at least for phenotypic data analysis.
Yeah. But I'm also thinking about not only for breeding, also about phenotyping gene banks, our gene banks, future seeds. we have a lot of valuable seed banks that there's a lot of material in there, and I guess we should also try to roll out not only towards breeding but also towards gene banks.
Yes, but I don't know if in this moment the gene banks, for example, Future Seeds is implementing this kind of analysis to analyze the phenotypic data that they are collecting in this moment. I don't know.
All right, thank you.
Okay, my pleasure.
Okay, thanks, Sebastian. Let's see if there's another questions or comments in the audience. Thierry, please go ahead.
Yeah, I think in the gene bank, in Future Seeds, they have phenotyping data like in a database from accumulated over several years. Maybe maybe it needs to be updated because there was several years of collection of data, and then at one point there was like a slowdown and there was less data collection, and now it might be useful to go back and see exactly what phenotyping data are there available in the current databases and see how to complete them, or to update the process to calculate the selection index and so on.
Not only for that, even for calculate the best estimate linear bias predictor, because this is the way that we use to see the real performance of each genotype or each section. Yes, we need to work on that. Thanks, Thierry.
Okay, let's see if there's more questions. In the meantime, I want to invite you to tomorrow's seminar. We have a tomorrow seminar about Terrai web tool for coffee farming in Vietnam. So we're going to have a presentation from our Hanoi colleagues that are working in this web tool that use remote sensing technology to help suppliers source agribusiness monitor. So it will be very interesting tomorrow at 4 p.m. in CES time or 9 a.m. here in Latin America, in Colombia. Okay, guys, let me know if there's another questions or comments pending. If not, I will share this presentation and recording in a few days, so many of you can make questions to Luis Fernando, or I'm sure that another question will pop up with people that couldn't attend today. So here's Oluwafem. Would you like to open your mic? Do you have a link for the webinar? Yes, I will like to have one.
Yes, thank you very much for that presentation. So what I want to ask, can we have access to the recording, because I'm very busy right here in the lab, so I could not follow through to the end. Can we have access to the recording?
Of course.
After this seminar ends, the recording is in the channel, the Teams channel, and if not, you can reach me out. However, I will share the link sooner. Okay?
Okay, I'll reach you out through your LinkedIn profile, because I got the link from there.
Okay, no problem. I will share it with you.
Okay, thank you very much.
Thanks to you. Okay, people. So we still have some minutes. If there's no more questions, I think we can close. Let me know. Okay, I want to thank Luis again. Sorry for at the beginning, I lost my connection, so I was get a little bit lost. But I want to thank Luis for taking the post and sharing with us this experience and this research project that I'm sure that could help and could support any other crops in the Alliance in the future. And anyway, it's so important to share the knowledge to all the teams. Thanks again to everybody for being here, and I hope to see you tomorrow. We have a interesting seminar tomorrow, and we're facing now the end of the year. Thank you, Luis.
Okay, thank you, Jose, for the invitation, and thank you all for being here. Thank you so much. I'm open to your question or different doubts or Q&A through my email. Please don't hesitate to reach me out.
Thanks a lot. Thank you, everybody. See you next time.
Okay,
Bye-bye.
see you next time. Thank you. Thank you all.